What I would like to do now is go through the Markovian analysis of the behavior data that you collected initially. This is not the analysis that you will use for your observations that you're currently making. Uh, this is for the data that you collected out on academic terraces when we were all there out as a class. What I've done here, everything is on one Excel page, and that Excel page or that Excel file is available to you on the web page. The first thing I did was I set up this matrix of sequential behaviors, and I've limited it to just the same behaviors that are on the data sheet that you're currently recording. So what you should do is take your other data sheets, the ones that you made out on academic terraces, and simplify them to these 6 behaviors. So was the animal vigilant? Was it foraging? Was it alert? Make sure you have a clear definition in your head of what the difference between alert and vigilant is. Was it feeding? Know the difference between feeding and foraging. Was it being social? That could involve a mating chase or mutual grooming or greeting an offspring or something like that. And then anything else would fall under other. So if it was moving, climbing, doing something like that, that would fall underneath the other category. So what I've done here is I've just made up some data. These aren't anybody's numbers. So in this example, the first time I imagined I saw this animal, it was being vigilant for 10 seconds. The next thing it was feeding for 30, alert for 10, and so on. And I have here 20 sequences. You may go on and on and on here, whatever's needed. Don't go past 400. None of this will work past 400. Actually, none of it will work after 395. We can change that. It's not a problem. It's just how I've set these equations up. So once you have that behavior matrix in, all of these other things here will fill in automatically. Here I have a series of smaller matrices which are just filled with zeros and ones. And if you look at the formula for each, here, for example, this first one, for this transition indicator matrix, I'm looking at the transition from vigilance to foraging. And you can see where does that happen? That happens right here. Okay. So here the animal is going from being vigilant to being foraging. So here, this refers, if I highlight on the equation, which is given up here, you can see it's going from vigilant to foraging. Obviously, that didn't happen here. So what the equation is saying is if this entry here is 0, right, then record a 0 over here. Otherwise, if it's not equal to 0, then the next question is, if this foraging square right here is greater than 0, then put a 0 there. Otherwise, put a 1. All right. Whoops, I'm sorry. If it's greater than 0, then put a 1. Otherwise, put a 0. So you can see that we have a 0 there. The one where that doesn't happen is right here, where we're going, right here, where we're going from being vigilant to being to foraging. And you'll notice there is our value right there. So it works. And notice what's happening here. We're going from vigilance to foraging and so on. Notice we don't have to fill in the vigilance. We'll deal with vigilance to vigilance later on. Here it's the same matrix, except now I'm starting with from foraging to alert, and because I don't have to worry about foraging to foraging, and I'm dealing with foraging to vigilant later on. Now I've made the matrix even smaller. Notice what I'm doing is I'm just going in one direction, right? I'm going from social to other, okay? And now I'm flipping it and I'm going backwards, right? So now I'm going from foraging to being vigilant, from alert to being vigilant and alert to being foraging or to foraging. So you can see that we're going in the opposite direction here. We're looking at all possible transitions. And now what I've done is I've filled in this time matrix. So this time matrix is filled in on the diagonal at least with the total time that the animal went from being vigilant to being vigilant. So here the animal spent 80 seconds going from vigilance to vigilance, 86 seconds going from foraging to foraging, and so on. And let's look at this. This is from vigilant to foraging. So that's the sum of my columns here, L6 to L400. Let's go find L6 to L400. There you go. That's in the step 2, so I'm summing that, and here you can see this is why I'm saying don't go past 395 observations. If you do, we'll have to change these equations, but I don't think anybody is going to have that many observations. So here's our time matrix, our time and transition matrix, and here I'm actually computing the transition matrix. So first let's look at this column. This is simply the sum of all the transitions where the animal went from being vigilant to vigilant, vigilant to foraging, vigilant to alert, vigilant to feeding, to social, and to others. So these are just the sums of these rows over here. And I'm using those sums now in this matrix, right? So now I need to convert these to probabilities. So this is the probability of if you're vigilant, then transitioning into vigilance. And you'll notice what that is. That is simply my CD5. So let's go find CD5. That's this entry right here, right? Divided by the total time the animal was being vigilant. So what do we have there? 95% of the time, if the animal was being vigilant, it continued being vigilant. And we fill in the rest of this matrix in the same way. So this then is our transition matrix. Now we have two options here. We can either solve the characteristic equation for this matrix. It's a square matrix, right? So it's 1, 2, 3, 4. It's a 6 by 6 matrix. So we could solve the characteristic equation, extract the eigenvector and the eigenvalues, which would require that we do some linear algebra. That's beyond the scope of this course. So what we're going to do is simply take the brute force approach. And what I've done here is I've multiplied this transition matrix by itself, and I'm using the mmult command. So this is my transition matrix squared. This then is the squared matrix squared, so that's the transition matrix to the 4th power, transition matrix to the 18th power, 16th power, 32nd power, 64th power, 128th power, 256th power, 512th power, 1024th power. And you'll notice that what's happened now, if we compare this one with the previous matrix, all these entries are identical. So 0.21752, 0.21752, right? All of these things have stabilized. They're not changing anymore. So we've reached what's referred to as the steady state. So we've reached the asymptote on all of these values. And this then is my steady state vector. So if you'll notice, this is simply the diagonal of this matrix right here. That is my steady state vector. And that's the information that we want. So what this is telling you is that the animal is spending 21.7% of its time being vigilant, 23% of its time foraging, 11% being alert, 32% of its time feeding, roughly 3% being social, and so on. If we go back to the raw data and look at what we had for the raw data, these are the observed values. So here we just take the average out of all of its time. And you'll notice that these numbers are different. So here on other we have 8.7%. Here we have 7.3%. So the values that you're getting here are actually closer to the truth than these are. Why is that difference there? Simply because, as we mentioned in class, behaviors don't exist in a vacuum. You don't randomly jump from one behavior to another. Behaviors happen in sequences. So you have all sorts of sequences. Um, you know do certain behaviors in a certain order. You put your socks on before you put your shoes on, right? You don't put your shoes on and then put your socks on. There's a specific sequence. So that's what I'm asking you to derive for the data set that you collected, those observations that you made out on academic terraces. Compute this steady state vector and then compare that with the observed. All you have to do to complete this assignment is fill in this matrix right here. And of course, you'll have to continue down here. There are some circumstances where you may end up with what's referred to as an absorbing state. Don't worry about that. Just fill in these. If you have a matrix that has an absorbing state, we'll deal with that after you've turned it in. No points lost for that. That's not something that you can control. Okay, so get these. Use this as your template. Download this file. Plug your numbers in here, right, and it'll do all the computations for you. Should be pretty straightforward and pretty easy to do. Good deal. Talk to you guys next time.